12th Science Chemistry Transition and Inner Transition Elements Study of Lanthanoids.
Hello students, in previous lecture we have studied detailed about the lanthanoids, that is about their electronic configurations and their oxidation states. Today we are going to study about the properties of F block elements. There are F block elements which is present in two series, that is first inner transition series, which are known as lanthanoids, in which lanthanum to lutetium elements are there. Total 15 elements are there, and which is also known as 4f orbital series elements. And the second inner transition series element that are called as actinoids, in which actinium to lawrencium 15 elements are there, in which 5f orbitals are progressively filled up. Therefore they are known as 5f series inner transition elements. Then elements which is present in both the series, which are F block elements, that means their n-2f orbital, that is per penultimate orbitals, are progressively filled up. Therefore they shows the common general properties. Then now I am going to discussing with the general properties, the common properties shown by lanthanoids as well as actinoids, that is the properties of F block elements. Then see here, properties of inner transition elements or F block elements. Then first the property which is shown by F block element, that is F block elements which having the similar properties like D block elements. D block elements are also metals, as well as F block elements which are also in metallic form, or they are also metal. Therefore most of the properties of F block elements are similar with D block elements. Then second property, that is electron, that is differentiating electron of those elements enters into the n-2f orbitals, that is n-2f orbitals are progressively filled up. That means in lanthanoids 4f orbital is progressively filled up, and in actinoids 5f orbital is progressively filled up. Then see here, these are, all of you studied about that, these are present in 6th period and 7th period, that is lanthanoid present in 6th period and actinoid present in 7th period, and therefore these are placed between n-1d orbital elements and S block, that is S block elements. These are lies between n-1d orbital elements and ns block elements. Then one more property of these elements, see here, that is lanthanoids. These are known as rare earth metals, that is these are known as rare earth metals. Why they are called as rare earth metals? Because similar like S block elements, they are also found in the earth crust. That means they are fairly abundant in earth crust. For example, thulium is more abundance than silver. Here it is called as rare earth metals, because while extracting of these elements in the metallurgical process, it is difficult to separate these elements while extracting process, because they shows similar properties, nearly the similar properties. Therefore, it is difficult to separate from each other. And therefore, for separating, the new technologies are used, that is ion exchange resin method. Like that method is used to separate these elements which having the same properties from each other. Then these elements are generally soft. These are soft metals and which having moderate density. Which having moderate density. That means nearly about 7 gram per cm cube is the density of those elements. And one more property, that is they have high melting point and high boiling point. Nearly they have more than 1000 degrees Celsius melting point and more than 3000 degree Celsius boiling point. That means they have high melting point and high boiling point. Then one more property, that those F block elements which having the similar chemical properties like S block elements. That means F block elements which having similar chemical properties like S block elements, and S block elements are alkali metals and alkaline earth metals. For example, as S block elements, that is alkali metals and alkaline earth metals, reacts with water to give their hydroxides. For example, NaOH, KOH, MgOH twice, like those hydroxides, as well as with water they forms the hydroxide and liberates hydrogen gas. Same like that, the lanthanoids, Ln is the general symbol used for all lanthanoids. Ln means any lanthanoid or any FO block element, or it is generally written like M. That means any FO block element, whether it is lanthanoid or actinoid, these reacts with water, or when it is dissolved in water, it gives MOH thrice like hydroxides, as well as it liberates hydrogen gas. Then see here, the any FO block element which in aqueous medium, dissolved in aqueous medium, it forms the hydroxides like having formula MOH thrice, and it liberates hydrogen gas. And this property is similar like the S block elements. Then these F block elements which having oxidation state, common oxidation state, that is +2 and +3 are the common oxidation state, but sometimes they shows +4 or higher oxidation state, that is +5, +6 or +7, but most common oxidation state shown by the F block element is +2 and +3. And for example, cerium shows +4 oxidation state, while actinoids shows higher oxidation state. Few of the actinoids shows higher oxidation state like +5, +6 or +7. Then here, for example, as they shows +2 and +3 common oxidation state, most of the +3 common oxidation state shown by those elements, therefore they forms the compounds like M2O3 type, in which that metal of F block element which shows the +3 oxidation state. That means, and europium and ytterbium which shows +2 oxidation state, and +2 oxidation state of those elements are stable, while cerium in +4 oxidation state, it is stable, most stable ion. That means this shows the common oxidation state +2 and +3, as well as they have, see here, they have low enthalpy of atomization. They have low enthalpy of atomization. Atomization, enthalpy means heat required to atomize, atom formation of those elements. That means enthalpy of atomization, the energy required, the heat required to form the atoms of those elements, that is called as heat of atomization or enthalpy of atomization. As they are soft, they have low enthalpy of atomization, because see here, due to n-1d orbital, transition elements are harder and their density is greater, therefore they have high enthalpy of atomization, while inner transition elements which are soft, because their n-2f orbitals are progressively filled up, therefore they have low enthalpy of atomization. Then one more property, see here, europium and ytterbium, which having low enthalpy of vaporization, which having the lowest enthalpy of vaporization and which having the highest atomic radii. Europium and ytterbium, which having the highest atomic radii, like barium. It is like barium, while barium is a alkaline earth metal. I have already mentioned that they shows the chemical and few physical properties like alkaline earth metals as well as alkali metals. That means europium and ytterbium, which having the highest atomic radii, like the barium, which is alkaline earth metal. And similarly, this shows low enthalpy of vaporization. Low enthalpy of vaporization. Enthalpy of vaporization, that means energy required to vaporize or vapor formation. Similarly, like alkaline earth metals, when they dissolved in ammonia, they forms the blue color. That means they dissolved in ammonia, or they are soluble in ammonia and forms the blue color solution. That are the properties of F block element. Most important property of those F block element, that is ionic radii or atomic radii. Ionic radii or atomic radii of those elements, that means F block elements of lanthanoids as well as actinoids, both. These are decreases from left to right. That means in lanthanoid, atomic radii or ionic radii, which are decreases from La to Lu. As the atomic number increases from La to Lu, atomic radii decreases because of their n-2f orbitals are progressively filled up and f orbitals which having poor screening effect, therefore their effective nuclear charge increases and gradual decrease in ionic radii or atomic radii from lanthanum to lutetium, which is also known as lanthanoid contraction. Similarly, that type of contraction is also shown in actinoids, that means ionic radii or atomic radii, which is decreases from actinium to Lorentzium. It is because of the poor shielding effect of n-2f orbital. That is, effective nuclear charge increases and atomic radii of lanthanum, that is 117 pm to lutetium 100 pm. That is gradual decrease in atomic radii and ionic radii, and which is shown in both F block elements, that is lanthanoid and actinoid. And one more property which is shown by F block element, that is they have highest coordination number. Have the coordination number in complex formation, that is 6, 9, 10, 12, highest coordination number. That means it is a total number of ligands attached or a total number of coordinate bond formed by the F block element, ions of F block elements in complex formation. These are the total number of coordinate bonding formed in the complex formation of lanthanoid ions or actinoid ions. For example, La3 plus ion, which forms a nonahydrate complex. Nona means 9, hydra means water. That means La3 plus ion, which is at central metal ion, which is surrounded by 9 water molecules, and these water molecules forms the coordinate bond with La3 plus ion. That means here these water molecules, that is aquo group, which are known as ligands in this complex. That means here 2, 3, 4, 5, 6, 7, 8 and 9 water molecules which surrounds to the La3 plus ion and forms the nonahydrate complex. That means it has coordination number 9. In this complex, coordination number which is 9. It shows highest coordination number, that is 12 in few complexes. Then see here, some chemical properties are also shown by those elements like S block elements. F block elements forms the hydroxides which having general formula MOH thrice. That means hydroxides of F block elements which having general formula MOH thrice and which are basic in nature like S block elements. See here, in lanthanum, La3 plus ion to Lu3 plus ion, ionic size decreases. Ionic size means ionic radii decreases from lanthanum to lutetium. It is decreases from lanthanum to lutetium. That means Lu3 plus which having small ionic radii, while La3 plus which having more or larger ionic radii, which is bigger ion La3 plus. Similarly, the hydroxide of these tripositive ions of lanthanoids, that is LaOH thrice and up to LuOH thrice, the hydroxides of the elements which is present between these two, the basicity also decreases from hydroxides of La3 plus to hydroxides of Lu3 plus. That means basicity also decreases. Basicity decreases from left to right. Therefore, LaOH thrice is the strongest base. While LuOH thrice is the weakest base. Next property, that is these lanthanoid which reacts with nitrogen present in the air, then they forms the nitride. Like LNN. That means which having formula LNN at higher temperature. That means on heating they forms the nitride, the nitrogen from air. they reacts with this, that is twice molecules of lanthanoid reacts with nitrogen gas to forms the LNN, that is nitride, lanthanoid nitride, which having the formula LNN. Then they also forms the compounds of halide when they reacts with halogen. Halogen like chlorine, bromine, iodine. Lanthanoid reacts with halogens to give the formula of their halides, that is LNX2. That means on heating they also forms the lanthanoid with halogen, whether it is chlorine, bromine, iodine. They forms the chloride, bromide, iodide of lanthanoids having general formula LNX2. That means, for example, if cerium forms the chloride CeCl2, then europium forms the compound that is EuCl2 or EuBr2, like that halides. Then when they reacts with carbon at higher temperature above 28 degree Celsius, that means any lanthanoid when reacts with carbon, they forms the carbide, and above 28,000 degree Celsius they forms the carbide like having the formula LnC2. For example, CeC2 or TmC2, like these compounds. That means carbides of those lanthanoids are formation takes place at higher temperature. Then see here, these are the general or common properties shown by lanthanoids as well as actinoids. Then we are going to discussing on the properties, that is general properties of lanthanoid, and these are the specifically applicable for lanthanoids. Therefore, first of all, we have to discussing on the properties of lanthanoids. Properties of lanthanoids. Then see here, first property, that is these are the lanthanoids which having the elements from La to Lu, and the elements after lanthanum are called as lanthanoids. That means from cerium to Lu, these are lanthanoids, but lanthanum shows the property similar like the lanthanoids. Therefore, lanthanum is also considered in it. Then property of those lanthanoids are, that is they are soft and having metallic characteristics. That means they are soft metal and which having generally fairly colored, or most of them are silvery or white in color. Then next one property, as they are soft, their density is moderate. Their density is, that is about 7 gram per cm cube. That means they have moderate density having 7 gram per cm cube. Their color or their brightness decreases when they exposed to air. If they are exposed to air, when they comes in contact with air, then their color get fade or they becomes the lighter in color. One more property, that is they are good conductor of heat as well as electricity. As they are metallic structure, they are the good conductor of electricity because they have mobile electrons in their atomic structure or ionic structure. Therefore, they are a good conductor of heat and electricity. Then see here, in lanthanoid series, PM, that is Promethium, is a radioactive element. Radioactive element, that means the element which emits alpha, beta, gamma rays from their nucleus of atom, and these are called as radioactive element. Then in lanthanoid series, only one, that is promethium, which is radioactive in nature, but while others are non-radioactive elements. Non-radioactive elements. And promethium, as it is radioactive element, therefore it is a highly unstable element. Then see here, though these elements have tendency to bind with water, and most of their hydrated forms are found. That means like lanthanum, which is found in nonahydrate form. 9 water ligands are attached to the La3 plus ion. That means most of them are in hydrated form. Then one more important property of those lanthanoids, that is lanthanoid contraction. Lanthanoid contraction. Then what is lanthanoid contraction? See here, the name itself indicates this property is related with lanthanoids. That is, it is applicable to elements from lanthanum to lutetium. And contraction means, that is, contraction means decrease in their atomic or ionic size or atomic or ionic radii as atomic number increases from La to Lu. That means La has 117 pm atomic size, while Lu has 100 pm atomic size. That means here gradual decrease in atomic size as atomic number increases from lanthanum to lutetium. This property of lanthanoids are called as lanthanoid contraction. Then see here, they have one more important property, that means they shows highest coordination number in complexes. They show generally 6, which is common coordination number shown by the complexes. 6, 8, 9, and sometimes they shows highest coordination number, that is 12. Then as they possesses, according to the electronic configuration, they possesses most of the n-2f orbitals are unpaired. Therefore, as those elements possesses unpaired electrons in their n-2f orbital, that is 4f orbital, therefore they are highly paramagnetic in nature. Highly paramagnetic in nature. And that paramagnetic property, which is measured by the different formula used for those elements. Then see here, the gadolinium, that is Gd, which becomes ferromagnetic in nature, like iron, cobalt and nickel. Iron in d block element, iron, cobalt, nickel are ferromagnetic in nature. That means it is the highest paramagnetic character. Like that, gadolinium becomes ferromagnetic in nature at lowest temperature. It is nearly below, that is below 16 degrees Celsius. Similarly, here terbium, holmium, ytterbium, and few other, that is thulium. These are the elements which also shows ferromagnetic property at low temperature. That means they becomes ferromagnetic in nature at low temperature. At much lower temperature, they behave like a ferromagnetic in nature. And their magnetic property and optical property, it is not depends upon any environmental factor. Then they also shows the chemical properties similar like the alkali metals or alkaline earth metals. That means they forms, lanthanoid forms the hydroxides, that is in LNOH thrice form. That means LNOH thrice form, which are basic in nature. Then they forms nitrides at high temperature when they reacts with nitrogen, and they forms the nitrides having formula LNN. They also forms the halides when they reacts with halogen, and they forms the halides which having formula LNX2. And they also have tendency to form the carbides at higher temperature, about 2800 degrees Celsius. That means 2800 degrees Celsius temperature. They forms the carbide having formula LnC2. And that is about the physical and chemical properties and the specific properties which is related with the lanthanoids. Then we will study detailed about the actinoids in next lecture. Thank you.